Example 8, let's go ahead and read that from the book. It says a deposit of $50 is made on the first day of each month in an account that pays 6% compounded monthly. What is the balance at the end of 2 years? Notice that you're making a deposit of $50 each month, and then you're also doing 6% interest, and you got 2 years. Right. So we're going to come back to our formula for compound interest. This was the one that talks about being compounded at different rates. And so what we have to do is we have to consider each deposit separately. Okay? So on our very first deposit, it's going to be A equals $50 you're putting down plus 1 over interest rate 0.06. Notice 6% became 0.06 over N, which is 12, because you're compounding monthly. That's where N comes from. Should have wrote that down up here at the top because it's also important. So N is 12, then 12 times 2 years, or 24 twelfths. And if I put that in the calculator correctly, 1 plus 0.06 divided by 12 gives me 1.005. So 50 times 1.005 to the 24th power. And that's how much you're going to have for that very first deposit. For your very second deposit of 50 bucks, the amount is going to be $50. 1 plus 0.06 divided by 12 for 12 times. This is where it changes a little bit. The second deposit will not be in there for a full 2 years. It'll only be in there for 1 year and 11 months. So we use the fraction 23 twelfths. Well, the 12s cancel, and you get 50 times 1 plus when I simplify this again, 1.005 to the 23rd power. And if you follow this pattern all the way down to the very last deposit, the amount is going to be 50 bucks, 1.005 to the first power. And I'll go ahead and explain how I got that. 12 times, it's going to be in there for 1 month out of the 2 years, so it's 1 out of 24. Like that, excuse me. It's going to be 1 out of 12 because it's going to be for 1 month out of a whole year. T is time, which is in years. So on this one, I went 23 months out of 12, because 23 twelfths, 1 month out of 12, 1 out of 12. And so for the very last deposit, 1.005 to the first power times non-equal sign. Okay? And so now what I have to do is I have to add up the first month, the second month, the third month, the fourth month, so all the way down to the last month. So that sounds like a sum formula. And it's going to be the sum of a finite because we have a definite ending geometric sequence. So our sum is going to be considered just like this. The sum starts at 1 going to 24 of 50 times 1.005 to the n power, where n just represents the number of months. Because notice, 2 years or 24 months in 24, it's going to stay 23 months, it's going to stay 1 month. Okay? And so that formula is a sub 1 times 1 minus r to the n over 1 minus r. So the very first month right here, we have to figure out that number. That number goes in for the very first month. So we'll type that in. 50 times 1.005 parentheses 24, oh, not, it's caret 24. Hit enter. So it's going to be, I just messed that up somehow. That's not correct. So balance up 24. So the first one, sorry, this is what we're used. We'll put the 1 right here for that. So it's going to be 50 times 1 point to the first power. And it's going to be $50 times 1 minus r. The r is 1.005 to the 24th over 1 minus 1.005. So for my calculator, 1 minus 1.005 here at 24, enter, divided by parenthesis 1 minus 1.005 parenthesis, enter, times 50, enter, and we'll have a total of $1,271 and approximately 60 cents.